Yep, recording has started. Okay. So the question was from the audience was when should you use OpenDCS versus when should you use Python? And I guess my response is if it's easy to do in OpenDCS, if it's easy to do in CCP using the standard methods of OpenDCS and CCP, then I would go that route. I would use it because you're going to be able to interact with that interface a lot more easily than adjusting Python code. So I would go that route. If it becomes too complex and you're grabbing it from a source, like you're parsing HTML, right? That probably is easier to do in Python. Or maybe you're grabbing a CSV file and you don't really want to set up the parsing in OpenDCS. You know, it's one line of code in Python to parse a CSV file and put it in Pandas. So that might be an easier way as well. So it's kind of, you balance ease of doing it with ease of being able to make a change. Okay, so data acquisition in the cloud. So the topics I'm going to go over are sort of just an overview of the current setup and sort of what the future setup will look like in the cloud. Overview of data acquisition, a little introduction of SWIM's Python, steps for converting your scripts, so what the steps you should go through to actually convert your scripts. And then I'll discuss SHEF as well and where that's going and what we're going to be doing with SHEF. So current system, just a little schematic here. Big box, that's your T7, your NetApp, right? We've got all these users, CWPA user, the DCA user, LDM user, things like that. Getting data from the National Weather Service, data is going to access the water. You got OpenDCS, and you got your websites, right? So the part that we are really concerned with here are your scripts that are under your CWPA user, your custom scripts that you have written. Those scripts could be, you know, getting USGS data, getting data from other sources, creating static web pages, and you might have some custom scripts that are actually running computations, grabbing data and converting it and storing it. So those are really the scripts that we are focused on in this workshop. There is a OpenDCS workshop next week. I believe it's going to be virtual.
Yes, they are
virtual components. So if you want to learn more about OpenDCS, that's happening next week. So in the cloud, a little more scattered. Basically here we have big cloud in here. That's our database, Oracle database. Got all the data for all the offices in a single database in Oracle. And then we're using sort of CDA to sort of grab and store data into that database. So we have CDA will be interacting with Cavi and SwimView to grab the data that you're using for your applications. You'll also be using Cumulus and Airflow to grab your grids. So that's how the Cavi and SwimView will be getting data, and that's what you'll be interacting with on your day-to-day operations. We have our public websites. That's the web team. The web team is dealing with public websites. And they are working and helping you guys convert your websites to modernize your websites for that. There's also LDM. So LDM, do you have any questions about LDM? You talked to Jeff back there, shaking his head. No, so Corel developed LDM, an LDM application that'll be running in the cloud to interact with the National Weather Service, to transport data back and forth between the national weather service. That will also interact with airflow. So airflow is a way to sort of stage Python scripts, essentially. So it's kind of like cron, but it's a way to stage Python script, your Python scripts that you're running to run every hour, every 2 hours, or whatever interval you want. And then there's also a user interface for it. So airflow will be where we'll be getting data from your data. We'll be running your data acquisition scripts. And I did put a little arrow here. So right, the data acquisition scripts go to airflow. It can also go to CCP. Like we just asked, Jeremy just asked that question, right? If it makes sense to put in CCP OpenDCS, go for it. If you want to keep it as a Python script, it'll be running in airflow. So what we're really focused on in this workshop, again, are these scripts right here. So we're just focused on this little section over there, but it's a big part of your workflow, right? You need the data to run your models. So we got to be able to get all the data in your database. We got to put it in the right format so that we can run it in Airflow, and then it can go into the database. We can talk a little bit about LDM a little bit later. Yeah.
Sorry, basic question. What's the acronym CDA stand for?
SWIMS Data API. Yeah. So it's just our API for interacting with the database.
Yeah, we had a lot of questions like within our people about what like CDA gets talked about a whole lot. And we try to just describe it to people. Hopefully, it's just a new software middleman. Do whatever you do in the new database.
Yeah.
And eventually, you'll have to be the middleman between everything going in and out. Right now, we can start to choose to use the action middleman with our existing databases because we're going to eventually need it. So right now, we would intentionally be putting a new middleman in there to ease the future switch, right? That's the right picture to have of what CDA is.
Yeah, CDA. Yeah, I mean it's an HTTP way of grabbing and storing data. So if you have an internet connection, you can interact with CDA essentially. So it's there are, and I'll go over this in a little bit, but yeah. So it's right on your server now. We're using DB API to connect to the database, grab data. You're getting a direct database connection that way. But CDA is just the other. It is the new way that we will be grabbing and storing data. And SWIMS Python is a wrapper around that to use CDA calls.
Yeah, I know what an API is. I just
Yeah.
So it's kind of related to something.
Yeah. Got it. So we're really focused here on converting those scripts so that they can go into Airflow to then run. So we need it in Python 3. We need it using SWIMS Python to grab the data and store the data. And that's really the direction that we're going. So I know this is a lot. But we're really focused for this workshop. We're focused on that one part, right, of our data acquisition. Yeah.
What's Airflow?
I'll go over it in a little bit. It's a application. It's developed by Airbnb actually, but it's now an open source application that allows you to stage ETL processes, extract, transform, load processes. So it's basically a way to run a Python script and stage it. Say it'll run every hour or run every day, and so forth. So Corel is hosting it, is doing the infrastructure for Airflow, and it's putting it in CWBI so that we can hook our Python scripts up to it, and it'll be able to stage those scripts and run them. It also comes with a web interface, so you can see what's running, see what's not running, see what is airing out. So I'll show a little bit later on, but essentially it'll be a replacement for your cron on the server. So looking at that little section, data acquisition workflow, we have we have Airflow, and I'll discuss Airflow more in detail in a little later. We have this first step, right? So we have our existing servers, our existing database, our local servers and database. They are running Python 2 scripts using Python, using DB API to grab and store data, right? We need to convert those scripts to Python 3 using some Python and CDA. And the first step to that is get those scripts running on your server right now, right? So we have the tools. You can get CDA running locally. You can install Swims Python. You can convert your script, and you can run it on your T7 right now, so it's getting your data. When we do that, we're now ready to put it into Airflow, right? So the first step is you got to get it running locally. Once it's running locally, then you're ready to start in the next step, which is running Airflow. Airflow against Python base. So for Airflow, we'll have a Airflow will sort of bring in the different packages that we'll have available on GitHub. So we have Swims Python. Swims Python is a GitHub repo. Airflow will bring that in and use it to store and retrieve data. We have a SHEF loader parser. So Mike Perryman has created, and Brandon Colsey at LRL have created a GitHub repo that will parse SHEF data, right? So there's a GitHub repo for that. Airflow will bring that in. And we'll have a data acquisition repo, where you will host your data acquisition scripts. And you'll be able to interact with that repo on your individual workstation. So all of that is sort of the future, things that you'll do later after we get our scripts converted. So really we should be focusing on this first step right here, and that's the focus of this workshop. This is the first step right here. Let's get your scripts converted. Let's get them running on your server using CDA, using some Swims Python on your T7s. And then we can then put that into the workflow of actually integrating with Airflow. Yeah.
Migrations. It probably will be, okay, your database, we're shutting that down on your T7. You can still run your CDA scripts on your T7. Like, we probably wouldn't do such a big jump where, okay, we're turning everything off the T7. Just probably, migrate that database. The database is in the cloud now, but you still have your T7, you're on CDA. As a stepwise process.
Yeah. I mean, you'll probably be running in parallel, in essence, right? So you have your scripts running on your server. You keep them running. We migrate those scripts into Airflow, and we migrated them into the cloud environment, so they're running in Airflow and they're running on your server, right? Once we're ready, where all your data has been copied, we confirm that all your data acquisition is happening in the cloud, right? And that's working. We confirm you can connect to Cavi, SwimZoo, do your operations. Now we're shutting down the T7, right? So it'll be a parallel process. So why Python 3? Why are we moving towards this? I mean, technically we could run Python in the cloud. That could happen. Could do it. But why are we trying to convert everything to Python 3? It's a couple of reasons, right? Portability of the scripts. If you're running a script in Python 3 and Swims Python, you can really run it on any system that you have Python, essentially, right? You can run it in a Linux system. You can run it in Solaris. You can run it on your machine in Windows. You can run it on a Mac, right? We're using CDA as the go-between. So as long as you have an internet connection, you can run these scripts on any different system. Python as a programming language is not being maintained. I mean, I guess it is being maintained by 1 or 2 people, right? But it's still running on Python 2. It's not running on Python 3. They have not made that jump. So you really don't have access to a lot of the libraries that are available in Python 3. You don't have access to Pandas, NumPy, Matplotlib, Plotly, things like that aren't available in that Python environment. And there's a whole host of libraries out there that you can use in your scripts. And you can stay up to date with the latest Python versions and optimizations. You know, we're not stuck on Python 2.7. We can go to Python 3.12, right? And go to the latest versions. And Python is well known and taught in many engineering schools. Probably the 3rd most popular programming language. So new hires coming in have probably been exposed to Python. So it's just well known. Yeah. Yeah. I mean, it's also a requirement for security purposes that we're using the latest tools, the latest security versions. So as I said, right, if you're using Python, you're available to use all these different libraries and modules out there. Number of companies are using Python for, machine learning, data science, things like that. They develop libraries. It's open source. You can use them. So this is just just a couple of the libraries that are available that you could use. Right, and the ones in the red boxes are the ones that are included in the environment file that we sent out that you can use right now. There's other libraries that you're like, hey, this would be really easy if I could use this library. Let us know. We can include it in our Airflow install. We can include it and you can use it. So, right, NumPy, Pandas, some plotting tools, Matplotlib, Seaborn, Bokeh, Plotly, web scraping. There's Beautiful Soup, which you can use. There's other ones I haven't used them before, Scrappy, things like that. Again, if you're parsing data and you're like, oh, this package will work really well versus Beautiful Soup, let us know. We can use it. We can install it. And once you get into Python 3, you can use all sorts of other things if you want. If you want to get into the data analytics on your data, you can use those packages. So there's just a number of things that are available that once you get into Python 3 that are available to you to use. And one of those is Pandas. So there are a couple of hands. Some people are familiar with Pandas. But really, Pandas is kind of like your gateway to using a lot of those other libraries. So a lot of them use Pandas as the base program. So you got to get it into a Pandas data, your stuff into a Pandas data frame, and then you can start using a lot of the shortcuts and functions of some of those other applications. So, it's basically a way to, well, it provides fast, flexible, and expressive data structure design to make working with relational data both easy and intuitive. So basically it's two data structures, right? You have a series, which is a one-dimensional array, and you have a data frame, which is a 2D array, right? It's just got rows and columns. You have indexes for those rows and columns. It's like a table in Oracle. Links there if you want some tutorials on Pandas. Just check it out. We'll go through a little bit of Pandas, some functions during this workshop. But if you want to learn more, you can pretty much find it anywhere. In Udemy, you could find tutorials and things like that if you wanted to learn. There's a bunch of built-in functions to allow easy manipulation, organization, and plotting of your data. So again, there's another source. There's a group by function. You can group data by category. You can use a pivot table like in Excel. You can, there's a function for that. Merging and joining of data sets. It's built-in functions for working with time series data, plotting, saving the data, importing the data from various file formats, conducting stats, and again, you can easily use that data with other Python packages as soon as you get into a data frame. So for the people out there who know SQL, there's a table here that shows sort of your code in SQL and what a similar function would be in Pandas, right? So you can load data, view data, filter, sort it, aggregate the data, join two data sets together, create a new column, and so forth. So if you want a good one-to-one comparison, if you're used to working in Oracle, you can look at this table. There's also another link there that has even more information on those comparisons and some of those functions that you can use. So now, that's Python. What's Swims Python, right? Swims Python is a Python 3 module for interacting with the Swims database using CDA. It's a way for you as a district to be able to read and write data into a Swims database. And it can be used by the public. So the default URL that it's connected to is our public database in the DMZ right now, soon to be probably in the SWBI production database. So the public can use Swims Python to grab data from our database. So if another organization wants to get data or time series data from us, they can just use Swims Python and then they have it in a Python environment. They don't have to do their own CDA calls. They can do it in one line in Swims Python. So for CDA, most of you have been to the Swagger page in CDA and seen sort of the different API calls in CDA. Anybody who hasn't sort of seen a couple? Okay. Well, so if you go to the your CDA URL, it'll bring up in a web browser, bring up a Swagger page, and you can see the different endpoints that are available to grab and store data. So Swims Python is basically just a function that calls that endpoint and allows you to enter the parameters of that endpoint needs. So for time series, there's a get time series data, there's a post time series data, a delete, and a patch. Post and patch, pretty much the same thing. They run the same code in the background in Oracle. But so in Swims Python, we have a get time series. For posting data, we have a store time series. For deleting data, we have delete time series. For patching data, we have an update time series. So basically, different calls in Swims Python correspond to an endpoint in CDA. And here's a list of all the functions that we are going to use in this workshop. Write them all down. So we're really focused in this workshop on time series, locations, ratings, and and ratings, essentially, right? So there's functions for time series, right? If we want a time series group, get a time series group where there's function for that. Again, to get time series data. There's also a function where if you have data in a data frame, it will convert it to JSON that CDA needs to store that data back in the database. We'll go through that. Then we have the same functions for location, same things for ratings, rating specifications, and we'll go through each of these and explain what each of them do. You can also display your catalog. So in SwimView, when you open up, you got the time series tab. Essentially, you got the time series catalog, which will display all the various time series in your database. It can be slow if you run it for all of it, and if you have a lot of version data. At the moment, it's slow. We're working on fixing that. And then the location catalog. The other endpoints that have been added, and this is stuff added to CDA, it gets added to Swims Python. There's forecasts, levels, location levels, standard text, binary text, text time series. Each of those have a get, a store, a delete, and so forth function. I posted some of the other ones that are just a little different. Location levels, you can get level as a time series, so it'll give you the same information that you would get from a time series call. Standard text, there's some added functions for that are different from the get, store, and delete. But so if you use any of those, there's some added functionality there. So the next release, you guys should currently have the newest release that you're working with for this workshop. Next release will incorporate new CDA updates. They're adding a lot of CDA stuff for Reggie. So a lot of outlets, projects, things like that Reggie uses. They're adding those, and as they add them to CDA, they'll be incorporated in Swims Python. Added functionality to save crit file information into a time series group, and I'll go over a little bit of that, but there'll be a function where you can provide your crit file for SHEF data processing, and it will automatically grab the data from the crit file and store it so that our enterprise functions will be able to use it and store your data correctly. Again, in the next release, there could be user requests. So as you use Swims Python to convert your data acquisition scripts, if you find something that you're like, oh, I wish this was a function in Swims Python, right? I'm repeating this code over and over in all these different scripts, right? Let us know. We can probably you can put an issue into the GitHub repo for Swims Python, or you can contribute it yourself, right? As you use it more and more, let us know what we're missing. Yeah. Yeah. So all updates right now, all updates gets pushed to SWI test first and get tested there. Yeah. And then once we know that they're working, then you get pushed to production. There might be a dev, a test, and a prod. So you'll have to stage changes through that workflow. It's never just push something to prod and just hope it works, right? Yeah. So you're on your local CDA instance or on the DMZ one? Yeah. So at the moment, we're not pushing updates to CDA to your local T7s. You have to go out and see that there's an update and grab the WAR file and install it. Right? Yeah.
That's what we did.
Yeah.
Oh,
Yeah, yeah, yeah. To the DMZ one?
yeah.
Yeah. I'll have to check. I don't know if the DMZ has been updated. The DMZ used to be probably a couple months ago really, really old. So it was a really old version of CDA. And wasn't the same as SWBI test. And probably wasn't the same as what you had locally. So something might have broke when you installed in the version that you installed. But I would check against SWBI test. And if that's still broken in SWBI test has the latest version. It's still broken in SWBI test, then it's an issue to CDA to say, hey, this is broken. It's not working. Yeah. Yeah. Gotcha. Okay. So any questions, any other questions on just sort of that overview? Sure, there's lots of questions, but. Okay, so the focus of this workshop is converting your scripts, right? So what are the steps for converting those scripts? I'm sure some of you are probably feeling like this, rubbing your temples. But so step one, right? Step one is get CDA running on your server. You're set up your T7 server, right? So get CDA running on your server, get SWMS Python on your server, set up a local instance of CDA. If you haven't done that and you are having issues with it, let myself, Mike, Charles know. We can help you get it set up. So I know there's some offices where there's a couple offices on one server, and I think they're working through that. No, not you. Not you. Not you. Yeah, no, I know. Okay, as in Mike and working on getting that set up. Yeah.
So Charles Graham is putting together a task force to help with those districts.
Yeah.
You're gonna pass that by someone who's not here.
Right, set up your local instance. Create an API key for your local instance, because that's the way you're going to be able to write data to CDA. You need an API key to do that. Set up SWMS Python. And to able to run SWMS Python with CDA, there's some certificate setup that you have to do. And there's a new version of SWMS Python that's available on everyone's server. It's 3.9.18 version of Python. So you should be using that one to run your scripts. And these steps are all in this link up here, more detailed in here than what I have here. But they're all available in the cloud migration website that we have for you to do. So we need, in order to start working and running these scripts on your server, you need to have this set up. If you already have SWMS Python on your server, confirm that it's the newest version, 0.4.4. If not, update your version, and you can see what version you have. If you do a pip show SWMS Python, it'll show you what version you are. It says 0.3. If you have an older version, please update it. And for that, you just do pip install swims python -u. And that'll update it to the latest version. So set up a local workstation environment. So you don't have to do all the coding on your server. You can do the coding on your workstation in Python and then move it over to the server once you know it's working, right? Because you can interact with the server directly using CDA from your workstation. It doesn't need to be on the server, where in DB API, it was a little harder to do that on your workstation. So all of you should have done this step, setting up the local workstation environment. If anybody hasn't, let me know. We can set it up. But hopefully everybody has that working and running using VS Code, using that environment file that we have. And for people online, these steps are in the team site under files. So you can find the setup steps to set up your local environment that way. It's all in the Word documents, Swims Python workstation setup. So look at sample scripts. So we have the new get USGS script. Mitch has converted a couple scripts for his data acquisition. And there's this website or GitHub repo, Swims data acquisition Python. And there's a couple scripts there already set up to run and use Swims Python to grab and store time series data. So we have it from Get USGS. We have it from Environment Canada. So if anybody else is grabbing Environment Canada data, Mitch has a script set up for that. What's the third one? Okay, weather service precip data. Mitch will talk about those tomorrow. So look at sample scripts. And if you look at a sample script and it's like, I need data from this source, oh, there's already a script for it, right? Use it. And that's part of us being here, is figuring out who has similar data sources. We're not going to put 3 different scripts in Airflow that are grabbing data from the same source. It's going to be one script. So if you're grabbing the same data as another office, work together and we'll create a single script to grab that data. So pull in the API, the URL and the API key. So these are just some examples from the different scripts. Mine's a little more complex. Mine's a little more convoluted because I don't know why, but I did it that way. For the get USGS script, and Mitch is just using environment variables where he has in his bash RC file, he has the URL and he has the API key available. For the get USGS script, I had it passing in as an argument to the script. So you could run it locally on your Windows machine. You could run it anywhere. And you could pass in that API key and the URL that way. So you're going to need to pull that in to store data. So there are examples, again, on that GitHub repo for how to do that. Follow those examples and pull that information into your script. Don't put it in the code. Don't say API key equals and then post your API key in there. Maybe when you're developing a little bit locally, but I made the mistake. I did it. I posted it to GitHub. I had to obviously kill that API key and get a new one. So don't do that. Don't do what I did. So the next step is let's write code to grab the data from the source. You probably already have code to grab data from the source in your script right now, right? So test it out in Python 3. See if that works. Now there may be better ways to do it in Python 3. For example, scraping the website you didn't have Beautiful Soup available, and that might be an easier way to scrape a website than the code that you're using right now to scrape it. So there's some tutorials on that on Beautiful Soup if you wanna look at that. Grabbing files and CSV directly into a data frame, right? You don't have to, in Python 3, you don't have to open the file, loop through all the lines, and append a list or something like that, right? One line of code, PD, read CSV with the URL. If it's a CSV file, it's in the data frame. And there's some things to remove headers and things like that. But it's one line of code. There's no more looping over the file. Unless it's a complex file, you really don't need to loop over it. API requests, there's a request package. You're probably going to use request packages available in Jython as well, but there may be other ways to interact with that data from that API. Things like that. So, try your existing method, but there may be a better method available to you because you're not working in Python 2.7 anymore. So once you have your data, you have to convert it into a data frame or well, eventually it has to be in JSON, right? Because that's what CDA is grabbing and using. But we have to convert it into a data frame. So for time series data, this is the data frame that you have to convert it into to work with since Python. We have datetime, we have value. Quality code is not needed. You can leave that column empty. You can leave it off your data frame. Really, you need datetime, value, and then there is a function that will take that data frame and convert it into JSON, and then you write it to the database using CDA. So CDA works in JSON format over there. You can save it directly into that format if you want. If it's easier that way, go for it. But you do need those parameters, name, office ID, units, and then the values has to be a list of lists, essentially. So you can do that, or you can, if it's easy, if you're grabbing a CSV file and you're importing it directly into a data frame, you can use that as well. Yeah.
How many time series index data frames, or specifically have a datetime column?
I have a datetime column.
Okay, yeah, and so that's required for JSON.
Yeah.
Okay, at the moment.
Or maybe do it both. I went back and forth.
Yeah.
I mean, yeah, if you're using if you're using the data frame, it's best to have it in the index column. I had its own column. It's the same thing the USGS does in data retrieve Python. So I was sort of going along with that format. Yeah. No. It can, so to put data into CDA, it does not have to be in UTC GMT. It can be the time zone. You'd have to add the time zone onto it, and we'll have examples of that to show you as we go through. Data you get from CDA is all UTC. So you can't get data from a different time zone, but you can store data as a different time. Yeah. Okay. Yeah. So next step is we have to define a method to map data to a SWIM's time series ID, right? So a lot of times this is hard coded in the script itself. Right? You're saying I'm grabbing this data and it's going to this time series ID. Maybe you have a dictionary or something set up in your code. Maybe you have a parameter file on the side of your script that stores this information to map an ID from your source to an ID in SWIMS. It's a little harder to do I guess, I mean, it can be done, right? It can be done in Airflow. It can be done inside the script if you want. But again, making those changes is a little bit harder to propagate those changes through. It's not as if you're working on your system. You can quickly change code in your script, and now it's automatically running. So if you need a new time series ID, you can just add it to the script and it's automatically running. It may be a couple days to propagate that from your local tests into Airflow, right? There has to be tests that have to be run. You have to check and make sure it doesn't break anything. You have to run it in a test environment, in a dev environment, a test environment, production environment. There's steps you'll probably have to take. But if we can use existing functionality in SWIMS view to do that, then it's a lot easier to, or in the database even, it's a lot easier to make the changes. It's not in the code. It's stored as like so for get USGS, it's stored in a time series group, and I'll show that in a little bit. So we need to think about a way to map those IDs to a time series ID, then in the hard code itself. So there's ways to do that. You can use time series location groups, which are available in SWIMS view, so you can interact with it in SWIMS view and make those changes. You can use things in the database, right? You can't interact with those in SWIMS view yet, but on your local machine, you can interact with them using CDA. So you can make that change in a standard text or a CLOB or something like that. You can make that change using CDA, and it's not in your actual code itself. So for the get USGS script, we're using time series and location groups. And so for the get USGS script, there is a time series group called USGS TS data acquisition. And if you get the new schema update, which has been released, some people have gotten it already, you'll have that time series group available. So in order to get data from the USGS and store it into a time series, you just add your time series to this time series group. You need to add another station. You just go to SWIMS view and add that new time series into the time series group. As long as there's information, a time series in that time series group, and a location alias that points your location to a USGS ID, as long as you have those two pieces of information, the script's automatically going to pick it up and it's going to grab it and store it in your database. And you can also use these attribute and alias columns to store other information you need. So for the USGS script, if it's a standard parameter, if it's like flow stage using 60 or 65, the USGS parameters is standard, you don't need to do anything. But if it's sort of a custom parameter, you can store that in the attribute field, and the get USGS script will grab that and grab the correct parameter that it needs to store into that database, into that time series. Yeah.
You guys, if you need to add some specific data acquisitions, we have two states that would be pulling data from. I'll do that.
So you're pulling data from two state agents,
Two state agents.
and you want to set up a time series group for, is that what you're asking?
Yeah,
Yeah.
that's how we're pulling stuff in now. That's how we roll.
Yeah, so you want to set up your own time series group, right? So it depends. If there's multiple offices grabbing data from that source, we can set it up because the owning office would be SWIMS, essentially. But you can create your own.
We can create our own.
You can create your own time series group and it'd be owned by your office, but no one else would see it. So that's why if it's multiple offices grabbing it, it'd be owned by SWIM so that other people can see it and add to it and use the same script. But if it's your own data, no one else is doing it, you can create your own time series group and store that.
So like right now, get USGS, it's separate, whatever, forever file.
Yeah.
So this would replace that. Would this replace anything that's like this .crit files for data stream? It's all gonna be done in Swim. Right?
Yeah. Yeah, so the crit files also will be stored in a time series group as well. So that information we store there, and I'll show when I get to chef data, I'll show how that's
And
gonna look.
They're gonna edit it. Right?
And then you edit in some.
Line by line, not. So the crit files, and the office are not.
Yeah, and we've developed an import script. We're developing an import script that's almost done. Yeah.
Okay, perfect.
Yeah. No, yeah. So again, for the get USGS script, there are certain time series that have multiple time series for one location. So you may have something like this, like for this location, this site, it's got these TSIDs, they call them method TSIDs. But it's for, discharge of conduit 1, discharge of conduit 2, discharge of conduit 3. And for that, you use the alias field and you can enter in those numbers if there's multiple for a certain district. So that's for the get USGS script. And again, during the workshop time, if you want to start setting this up for the get USGS script, we can get together and we can all work on it and get it set up together. But I'm just using this as an example of how we can use time series groups to store this information. And so once we have it all set up in the code, right, we're going to grab data from the time series group. We're going to grab the information from the location group. And then we're going to use Pandas to merge those two tables together. And we end up with a table that has time series ID. It has your USGS parameter that you're grabbing. It has your method ID if you have one of those sites where it has multiple time series for a single site. And it has your USGS station number. So now we have all the information we need to go out to the USGS, grab the data from them, and now we know where to put it. So it's using those SwimView functionality to get that information. So now if you need to add a site, you're just interacting with SwimView. You don't have to interact with the program or some file or something. So it's just a new way of sort of thinking about that process. So what about chef data, right? What about chef? So for chef data, we are setting up a process, it's sort of an enterprise process. So if you're getting chef data through LDM and it's going into a data stream or whatever, coming from the National Weather Service, there will be an enterprise process for that, to process that data. You don't need to set something up for it. So HEC, Mike Perryman, Corel, LRL, Brandon have set up a chef parser and a CDA loader. So they have set up stuff, converted that script that was in Fortran, right? Whatever. Mike Perryman went through the process of converting that into Python.
All weather programs, they're in forever.
Yeah. So he went through that process and converted that code into Python so it can be used in Airflow. And then Brandon used that code to take the parsed chef data and is loading it using CDA. So it'll save directly using CDA. So there is a GitHub repo if you want to check out the code. It's a command line tool as well. But it also will be incorporated into Airflow. And if you have SHEF files that you're grabbing directly from an HTTP source, right? It's not through LDM. You're grabbing a file and you're processing it. It'll be using that same SHEF parser, SHEF loader process. So you don't have to develop code to essentially, you'll be developing code to grab the data, but the actual parsing and storing, that's been taken care of. So files that are not SHEF at the HTTP source really shouldn't be converted to SHEF. So I know some offices are grabbing data, they convert it to a SHEF file, then they put it in their data streams, and then it's stored, right? So that we want to cut out the middleman on that a little bit. So we would like to, if you're grabbing it from the source, use Swims Python to save it directly into the database. Like we should, right? Because you're grabbing it from a source, you're converting it to SHEF, then SHEF is the SHEF parser loader is converting it back into SHEF it, then it's converting into a format for CDA to load, and then it's loading into the database, right? We should just grab the file from the source, put it into a format CDA can use, and ship it out, right? So, might be, and we'll help you with that process. Yes. Matt. You have what? Yeah. Yeah. No. If anything's working in OpenDCS CCP right now, don't change it. Yeah. Again, if anything's working in CCP, OpenDCS, don't touch it. Everything is working in CCP, OpenDCS right now will work in the cloud. Yeah. No, go ahead. Yeah. 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 So
Do anything upset the apple cart. I think what Eric's talking about, if you're converting stuff to SHEF for your own use, there's easy ways to do it.
yeah.
And that was the easy way, and with the data stream we had at the very beginning. There's better ways to do it. Now, if you have another office that they're expecting SHEF from you, and you have this agreement with them, I mean, you're not just going to tell them what they have. I mean, well, good. That's
Well, we would like to. We would like to tell them. Yeah. So the national weather. Yeah. So event-based stuff. Yeah, we'll have to set up a process to, if you run a forecast and now you're sending a file for that forecast information to the weather service, convert to SHEF, it'll go through LDM, it'll be sent to them, right? But for regular interval stuff, like every hour you're creating a SHEF file and you're sending it to the weather service, we should really work towards the weather service using CDA. Because they can write their own script on their end to grab the data every hour and store it. But that may be a process on their end. No, you are not the only office. Every office does. Every office does. I mean,
I think once that installed, it's.
Yeah.
Here's time series. are.
The RC code is public. They're kind of like, they have their own like regional field bed, so, but your RFC may not. Okay.
Yeah, again,
One unit plans for probably would have, like, I know our right now, our, the high river one was the big stuff. Like they expected, we expected it to go back to their LDM, but they also, they use CDA as backup. When LDM freaks out, whichever agencies do the job to break it. They already, they thought about both. They, if they can do both, they would talk about it.
yeah, I mean, it's desired that they grab it from CDA. They can't, we can create chef files and we can send it to them, right? We can do that. But even, I mean, Carl talked to the National Weather Service about chef, and they were like, oh, we have our own API. Why don't you grab it from there? And we're like, well, they don't have all the data yet on their API, but they're like, but we'll get it there. So they're even going towards, I think, where they want us to use their API and not chef in the future. So hopefully down the line, stuff's gone. And we will just be using our APIs back and forth. But again, that's in the future, that's not for our initial cloud migration. So, and then this is just a little schematic of, so Corel has developed an LDM application. And essentially what the LDM application is doing is it's going to be grabbing data from the National Weather Service, storing those files in a location, and then it's going to send a message essentially to Airflow and say, hey, Airflow, there's a file here. You got process it, right? And Airflow will be watching that message queue, grab the message and say, okay, I need to go grab this file over here and process it. So there'll be a workflow and integration between LDM and Airflow to grab those files and process them. But really, in terms of you and your interaction with that, there will be a web application for LDM that will say, hey, what file do you want to grab? And then in SwimsView, you'll have your crit information, and that's really your only interaction, right? Then that file will be processed and it'll be stored in the correct location. But you're just interacting with that web UI and with SwimsView to do that process.
The national LDM will have the big giant library of raw files, and each of us can individually decide what to decode any of it for our own capability.
Yeah. Well, it'll have the library of files that you say you want.
We'd be able to see it. Yeah, I wouldn't be able to see everybody's stuff, but that doesn't matter. Or the library, whatever we all sign up for, will be sitting there. And then we would just decode what you're not going to try and decode everything into the national database.
No, it has to be defined as you want this file.
Yeah.
Somebody wants this file.
And that's not available yet.
No, not yet.
Is there any timeline, do you know?
I mean, the application's done, right, Jeff? It's just moving. Yeah. It's
The other environments. Mutation test.
Yeah.
Yeah, we're not going to go across.
Yeah.
So be able to service everything is SHEF partial. In test, they all have to be in test.
Yeah.
They all have to be in test.
Yeah, so Jeff said the LDM application is running, it's working in a development environment, but the infrastructure has to be set up to move all of those components into into our test environment, and finally in our prod environment, and we have issues with the contractors and doing that process. So it's there, it's running. Hopefully it gets moved soon. So again, for the chef data, the crit files, that also will be stored in the time series group information. So you can see the information that you would put in a crit file will be right there linked up with the time series. And we will have a script that will do this for you, so you don't have to do it.
Did we work out how you're gonna send things out over LVM? That's still. We're generating in a.
Yeah.
Cavity or whatever.
Yeah, it hasn't been developed, but yeah.
Do you think it's gonna be like both a cavity?
I would like it to, yeah. That's
And. Like originally.
Can.
Send an email, right?
Yeah, it can.
I have to send it to the server. We can directly to cavity, or I gotta send it to the server sends, and peak insert.
Yeah.
The caddy can't run that right now, right? It can't run the command on the server.
For what?
Yeah, we have, right now, we're generating SHEF files, forecast products or whatever in the caddy.
Yeah.
We still have to use our key server middleman to LVM and email the.
Yeah. No, I wouldn't.
The application line set up for you to be able to upload, bang you off, and where you find the product and look at it. Once you go out and take it to them, if you do that, you also have set up to where you should be able to program these to basically in the task is this, like the file. Things have those things have to be, they have to exist and be defined in the application itself. So you say this is the forecast file, this is what the name. So it's no, this is what and then it's set up and product in the application. Then you can start pushing it.
Yeah.
There is last time the connection to go out. So that's just what it is.
Yeah. My hope is, yeah, you can push a button in the cavity for this forecast and it can ship out the SHEF file. We haven't developed that process yet, but that's my.
And we wouldn't directly do it. We're not going to be directly running it.
Yeah. You're just putting a file.
We can send it to your thing and then it does.
Yeah, you would create the file. Yeah. You would create the file, ship it off to the LVM application. Yeah. So the final steps of your script conversion, once you have it in a data frame, once you have it in JSON, once you know where it's going, save the data, right? You're going to save it. You're going to do a store time series, and you're going to save that data. Try to implement some logging using the logging package in Python. And there are examples of that in the scripts that we're using. It'll just help with creating log files in Airflow. So try to implement that. If you're using print statements, try to convert that into like logging statements. Collaborate with other offices who are getting the data from the same source. Because again, we're just going to have one script per source. We're not going to have multiple scripts. And then that GitHub repo that I posted before, you can save your script to that. That's not going to be the final repo where we're interacting with Airflow. But if you have something done and you have it running on your server, save it to that repo so someone else can look at it. And if you want to post it there and have someone at HEC, me review it and things like that, we can do that as well. So we can collaborate with your script conversion. Yep.
Is there a list of scripts that already exist here that collaborate with other offices? So like USGS, if that one already exists?
Yeah.
Is there a list of all the ones that are already out there?
The only ones that exist right now that I know of are the USGS one, Environment Canada that Mitch has done, and then his Weather Service Precinct one. So those three that are up there are the only ones that we know that exist so far that have been fully converted. There may be others, maybe other offices that have done this already, but that's part of it. Let's post them up there. Let's collaborate, things like that. Next is stop your existing Python 2 script and DB API on your server and start using your new script. So that we fully know that if it's functioning and it works long-term on your server, right? When we get into SWBI, all we're really changing is the URL of the CDA instance that it's pointing to. No longer pointing to your local CDA, it's now pointing towards SWBI test, SWBI prod, whatever. And set up to get USGS scripts. So that could be your first one that you can run on your server to test because that script's done. So let's get it set up. Let's get it running. LRL has been running it for a couple months now. They found one bug that I fixed, but besides that, it's been running. And they have 430 stations that they collect. They said it's running faster than the previous script, so it's keeping up as well. It's all done. That's it.
Well, and that even
Go from rubbing your temples to happy. But of course, there's future steps, right? Our focus here is let's get them running on your server. Once they're running on your server, we will then start integrating it into Airflow. So really, when I get USGS script, 95% of my work would have been done in all those previous steps. Getting to Airflow was simply a copy and paste. I'm adding a couple tags to it on when I want it to run, and then it ran in Airflow. So there are so that process won't take as much time in terms of getting something into Airflow, and we will help with that process. And I can show that to you as well. So I don't know if we want to take well, I'm almost done. We can take a break in probably 15 minutes. So how scripts will run in SWBI, Apache Airflow. Again, it's a pure Python platform to author, schedule, and monitor workflows. Comes with a UI user interface that provides full insight into the status of completed and ongoing tasks. Originally developed by Airbnb, now managed by the open source community. So it's been around for probably 15 years or so. We have our own GitHub repo for Airflow that we're working on. If you wanted to just poke around that, you can. And look at sample scripts, you can do that. But really, in terms of Airflow, I essentially add a new Python file to the Airflow repo. And I define some arguments in terms of the DAG itself. The DAG is just a way Airflow defines sort of a Python script. But I define some tags. I say how often I want it to run, hourly. I say I have some tags, so in the UI you can look up your Airflow, your specific DAG in the UI. I define some other tasks. I copied and pasted my functions that I had in the get USGS script into here. And that was essentially it in terms of setting up a new DAG in Airflow. And then the UI, user interface in Airflow, where you can see all the things that are running. Most of these see all the different tasks that are running. If I put in one of those tags, USGS, now here's my USGS script. I can start it over here, start it, and now it's starting scheduled runs, and it shows you if it's green, that it's ran and the task is completed. If it's red, it means it failed. We'll give you logs for that. Then you can go further in to looking at that specific day, and it'll show you. I at least divided up in tasks, so each office has a task, so they run in parallel. It's not complete one office and run the next office and run the next. They're running in parallel. So LRL, SWG ran for this run, and then you can see how long it took. Again, LRL had 400 and some time series. SWG had 6 in this example. So I can show you runs, and when we have all offices, each office will have its own. Yeah.
Oh, I wasn't trying to cut you off.
Oh.
But I was just wondering, so we can't have files load other like config files or things loaded on Airflow. Is there something in that LRL script that's using CDA to get the location levels and running it that way, or?
Yeah. So the script, you get USGS script, and you can check out the code if you want, but it's grabbing the time series group is grabbing the location group using CDA. It's
That's
developing
kinda how it's
that,
formulating.
and it's formulating that, and then it's formulating it. And then there's just some other information on Airflow. So again, right, I developed my script. I had it running on a server, and once I had it running on a server, then I knew it worked with CDA. Then I could copy it and put it into an Airflow DAG, and then set up some of these parameters, and then it could run. So, and this step of getting into Airflow, right? If you want to work in Airflow, and if we have, we'll probably have a group of people that will work directly in Airflow. If you don't want to, you can say, hey, I have a script, can we put it in? And there'll be a group of people that will help assist with that transition. And then this is just the logging. So if you have the logging set up in your script, you can view logs, hopefully view logs.
So there can be one, like basically one cron for all of us. Yes. And but we don't know how many people would actually be able to directly edit. Like everybody, hopefully a lot of people will be able to look at what those jobs are, but like that switch to turn off and on, there will be very few people to actually do that, right? Or is it?
Yeah. I mean, yeah. I think there would probably be a team that would manage that part of it. But in terms of your own scripts, the way I'm thinking about this, I'm hope to have this set up soon, is there'll be a GitHub repo where you have all of your individual function, individual scripts. So you'll have your script that will get data from Minnesota DNR, whatever, right? It'll be in a GitHub repo. That GitHub repo will be incorporated into Airflow, but you could also run that. It's a GitHub repo. It's using CDA. You could run that script from your machine. So if you got some one-off thing where I got to fill in the data for this specific time series or something, it's still available. You can still run it from your machine. Airflow is just the tool that's going to be running it every hour to fill in the data, right? So you would still have access to that. Okay. Yeah. All right. Questions? Comment? Well, yeah.
It's really not really a script. It is, I think it's a script with really a configuration file for the day written by.
Yeah.
There is a different level of thinking in it. It's not, you need to, you can't just, hey, I like Python, we can go right there. You really need to get a really solid innovation, name spacing, packaging, it's really a little bit of
Each egg, a separate container instance. No.
you have to get somebody else to come about detailed on buffers and schedules. Yes, if some of us that have a fear of just one a bunch of rags, if you could have these. Because they are sharing research. We could have 50 ads, and you can have one ad that's basically the ability to have and we can sell research. You buy a ad, you have to think about all of them in the ad. You can't just think of it. Have a blinders on, thinking about your own.
Will that be the sort of thing that smaller team would approve?
This is a perfect
making the live.
situation. Enterprise level. Team.
Yeah, and
To make
that's,
sure they will not, to make sure that my job doesn't blur.
Evaluate what you need. Already knew. And then,
The offices, each individual office should not expect that they can ever just add a new thing to the airflow column, right? It's gonna go through a middleman to verify.
yes.
I mean, we're not all gonna be experts doing that, that's never gonna happen. There's gonna be some smaller team that anything special you wanna do on the Neutron, right?
that's.
Yeah, I mean, that's,
So minimizing the number of automated jobs you have is probably also a very good idea.
Yeah.
for us.
so, and that's part of work together, right? One script per source, not multiple scripts grabbing data from the same source. If you're processing a certain type of data like PyXML, right? Probably be a processor for doing PyXML data. Maybe you're grabbing it from different sources, but a single processor to process that PyXML data, right? A single process to do that. So a lot of our stuff is going to be sort of combined together. But the first step in that is we need to know what we have, right? And that's why the first step before we even get to Airflow is get a script running on your server. Work with other districts if they're getting the same data to develop that script. Now, if we have it all running on your server, you're grabbing data from CD, you're storing data using CDA into your database. Now we can start that process of putting in Airflow. I didn't mean like thinking about the whole structure of Airflow, like that's complex. Part of if you have a script that's working and actually get it running in Airflow, a lot of that is copy paste, right? As long as it's a well-structured script and has been reviewed and things like that. So that part is the not easy step, but doesn't take as much time if you have a running script that works. I mean, there's lots of options in Amazon. There's lots. Airflow. We're moving forward with Airflow a lot because Cumulus already has it set up. It's already working with Cumulus. It has a nice interactive user interface, and it has a way of working with GitHub where you can make changes to it, and it's not creating a new image. It's just grabbing those changes in the GitHub repo and pushing it up to the existing image in AWS. There's Lambda functions, there's lots of other things that you can do in Amazon. And if someone wants to explore those options, you're more than welcome to explore those options. This is what we're choosing for right now to move forward with. Now we have a GitHub repo where we have all of our scripts as functions in that repo that work, either on your machine or work in Airflow or work wherever. We can put that wherever we want, essentially. Turns out Airflow doesn't work and we find some easier way. We can move it to that. So we're trying to make things that are portable that we can move if we need to.
Like the GTS, the first thing we're looking to line there. And the idea is that right now it's probably just LRL units. Oh no, this GTS just runs and makes everything available, and then the individuals offices set up and tools do what they're actually storing in portable.
Yeah.
Okay, so GTS done. Nobody has to. Nobody can. No, there's supposed to be that one running.
All you have to do is set up those time series groups and location groups, and it'll grab it.
That's all local, no Airflow, no special thing. Every instance that individually in their import, whatever.
Yes, I would like every office to have that script running on your servers right now, using that structure. So you get used to it, so hey, all my data is getting there, and if some data sets are missing, maybe maybe something isn't working correctly, we can test that out. So I would like that to happen. But as soon as if you have that running on your server and it's running and you're getting all your data, you don't have to do anything else with USGS data. It'll automatically be moved into Swift.
USGS. So our office, so we don't run it live on the server for a lot. We don't. A lot of people do. We do have it set up in the Academy run for a backup data. As a kind of local system. Back get USGS, and that's going to be stuff with those parameter files and little the TSID, all that stuff. That's going to come off the feed. Or we put that down to the Academy and manually.
Right now it can't work.
Manually run, you can't just get to the right of the forecast yet.
In a forecast CSS.
Yeah.
So you could. We don't have that process set up. I could probably look into saving the data into a DSS file if it's worthwhile pursuing. But you can run the get USGS script on your window on your machine. It would save it in the database. We don't have a process to say save to DSS instead. Okay, so let's take a break. When we come back, we'll start coding. So. Huh?
Recording. I think you should be able to just kill it and then restart it, right?
No idea.
I mean, I guess we could just leave it and I can cut it out later. It's too much of a trouble. Just let it run and I'll. There.